Hello everyone. Today I'm going to talk about my PhD project, which is mainly about a material selection study for sustainable short fiber composites. The constants we are using to make composites, fiber reinforced composite, needs sustainable solutions or alternatives, because the ones we are using right now, they are not environmentally friendly, renewable, and sustainable. So my project is focusing on two things, like making a material selection for the reinforcement material and also material selection for the matrix material, especially for the short fiber reinforced manufacturing method. So for hyperdiff. So what's hyperdiff? Hyperdiff is a water-based short fiber alignment method to produce highly aligned fiber preforms or composite prepregs, which offers high performance. And if we use the sustainable constituents, there is a sustainable route that we can produce short fiber composites like sustainably. So that was the whole motivation when I started. So then I started questioning what could be the potentially sustainable reinforcement material. So I investigated some natural fibers, especially the plant-based ones, in terms of their mechanical properties and the suitability with the composite manufacturing methods. I found that flax, jute, and crua, they are the good candidates. Then I used these good candidates with the hyperdiff method to produce some aligned discontinuous fiber composites. And also I use them as a reinforcement agent to give reinforcement of three common polymer matrices, which are epoxy, PLA, and polypropylene. Then I found that the flax that I got from France with a 6 millimeter fiber length is the best candidate owing to its mechanical properties, is suitable with the method because it gives a good areal density, and also for sustainability because of the current market status and logistical regions for EU and UK countries. So this negative pictures turned into a kind of positive picture. So I picked the reinforcement. So my material selection for the reinforcement agent is completed. Now the next question is what could be the polymer? What could be the potentially sustainable matrices? And which is going to have a good harmony with the flax fiber as well. I came across with several matrices in the field. I initially picked 3 of them because of their inherent characteristics and also representation of their family, and they offer sustainability, of course. The first one is from advanced thermoplastic family, which is ilium resin from Arkema. The second one is the bio-based thermosets. It's a Frocure from Bitres. And the third one is Witrimer, which is a new family. It's basically a thermoset, but it has a polymer network formed by reversible bonds. So this offers us to like features like remoldability, reshaping, reusability, covalent welding, and some of them also recyclable. So then I checked these systems' interfacial properties with the flax fiber. I performed some microbond test. I found that Frocure and Witrimer are better than epoxy and ilium resin. And there's also no statistically significant difference between Frocure and Witrimer, so they are the best candidates. They are both thermosets. However, Frocure, the completely bio-based thermoset, as far as I know so far, they are not recyclable. On the other hand, Witrimer is the one I use from Malinda Witrimax is recyclable, and also gives some features like remoldability and repair or reuse. So I completed this material selection journey by choosing reinforcement material as a flax and a resin so this is the best combination. So okay, that's the end of the material selection journey. Then I also produced some composites out of it. And I checked the repair performance. I didn't find something unexpected. I only recovered the 50% of the mechanical properties, but I was just doing the testing, then repairing, immediately testing, repairing. And then I also used the patch method to see if it's going to give some kind of reinforcement effect, which it gave. When I detailedly investigated what's happening in the system, basically the aligned fibers, they are really important in the fracture region. So I have to protect them to get better from the system. So in the future, as a future work, so material selection journey is ended. Now finding the best strategy to repair this material system is going to be the future work. Thank you very much.